Hi class. Today we'll be beginning our new unit, which is the final unit on electrochemistry. We should have plenty of time to get this unit completed. The notes package here is up as an attachment. Okay, so you need to get the notes package down. Okay, so let's look at what electrochemistry is all about. So this is a branch of chemistry which is concerned with the conversion of chemical energy into electrical energy. Okay, so um, having what we call a spontaneous reaction that produces electrical current. Okay, so that's kind of what we're looking at. And so that's an example of something like that would be a battery. So here's an example of what we call an electrochemical cell, okay, which is just basically a battery. We're going to get into more of the specifics behind how this works and the different parts later on in the unit. Okay, so what you have here is basically two separate containers. Um, these are nodes, and the voltmeter is just there to pick up the voltage that's running through the external wire. This is a salt bridge that's connected to the two solutions and is basically there to maintain the ionic charge. And then you've got uh, the solutions that are containing what we call electrolytes. Okay, so like I said, I'll get into all the specifics behind what the different parts, like I mentioned the word node, more specifically one's an anode and one's a cathode. So we'll get into all that, positive, negative terminal, how do you determine how much voltage is going to be produced, all that stuff we'll be getting into later on. Okay, but basically what you're looking at here is a reaction that's going to produce electrical energy. Okay, so this is a full reaction right here. And so another way to describe this reaction, we'd call this a redox reaction. Okay, so a redox reaction, a full redox reaction, is a reaction that contains reduction. Okay, so that's the first part of the word, and oxidation. And this full reaction can be split into what we call half reactions. So this is the full reaction. These would be the component half reactions. So there's one containing the silver and another one containing the copper. So let's look at the difference between the two of these half reactions. So let's just define oxidation and reduction first. So oxidation is the half reaction in which a species loses an electron, and redox reaction is where you gain electrons. Okay, so this, if you memorize this statement right here, you'll be able to distinguish between the two. Leo, the line says GER, so loss of electrons is oxidation, gain of electrons is reductions. So how do we know which one's which? So let's look at what's going on with the silver. So you've got 2 Ag plus, okay, so silver plus ions. You're adding 2 electrons, and by adding 2 electrons, you lose the positive charge. So here you've got silver metal, which has a 0 charge. So this would be an example of a gain in electrons. You're gaining 2 electrons. So this would be an example of a reduction. Okay, so that's a reduction. We would call that a reduction half reaction because it's not a full reaction. The other one, you've got copper metal, 0 charge, and then it's producing copper 2 plus and 2 electrons. So what's happening here is you're losing electrons, so this would be an oxidation half reaction. Okay. So in order for you to have a redox reaction, you must have one of the half reactions undergoing reduction and the other half reaction going through oxidation. So if you're missing one of those, then it's no longer considered a redox reaction. So here's the full reaction, and you notice there's 2's in front of the silver, and that's having to do with the charge. Okay, because you've got copper, the mass has to be balanced, but the charge also does as well. So if you look at this, you got +2 on the left and you have +2 on the right. Okay, so we'll get into how to balance redox reactions. This is a very simplistic one. They get quite a bit more complicated. So we'll look at how we go about balancing redox reactions. It's a lot different than what we're used to in any of the other reactions that we've looked at balancing. Okay, so this is kind of a unique reaction to balance, and there's a set of steps that we have to go through to be able to balance that. Now, because something is being reduced and something else is being oxidized, what we say is that is being facilitated. So for example, whatever is being oxidized is being oxidized by what we call an oxidizing agent. Okay, and then conversely, whatever is being reduced is being reduced by a reducing agent. Okay, so like we said here, let's just go through this full reaction now. So Ag plus going to Ag 0. Okay, so what's happening there is this is being oxidized. Sorry, this is being reduced. Okay, because it's going from positive to 0. Copper is going from 0 to positive, so this is being oxidized. Okay, and then the other way to look at this is the silver. We can call this the oxidizing agent. Okay, so it's the oxidizing agent because it causes the copper metal to become oxidized. And so you notice the oxidizing agent is reduced. Okay, and then this one here, the copper which is being oxidized, you can also refer to that as a reducing agent. Okay, so it's a reducing agent because it causes the silver plus to become reduced. Okay, so another way to look at things, a species is being oxidized if it becomes more positively charged. So remember, the atom structure is such that the protons and neutrons are in the nucleus, so they're going to stay as is. So the only thing that can happen is you can bring in electrons or take out electrons. So if something is becoming more positively charged, that means you're losing electrons, and so that's why it is oxidized. And conversely, if something becomes more negative, that indicates that electrons are being brought in, which means that it's being reduced. All right, so if we look at, let's look at this reaction here. So we want to indicate the species oxidized, reduced, oxidizing agent, and the reducing agent. So just rewrite the reaction here. Okay, so let's look at what's going on with the copper. So we got positive charge and then 0 charge. So what that tells you is the copper is picking up electrons. So this is being reduced. Okay, and so because it's being reduced, it's also the oxidizing agent. Okay, the aluminum is going from 0 to +3. So that indicates that you're losing electrons. And so therefore this is oxidized. And then this would also be considered the reducing agent. Okay. Now notice what's different about the full redox reaction in comparison to the half reactions. So the half reactions, they show the electrons, but the full reaction does not show the electrons, because what happens, and we'll get to this later on, is essentially what you're doing is you're adding the two half reactions, and you should have just as many electrons on the left hand side as you do on the right hand side, and so when you add them they cancel each other out. And this is one of the things that has to happen in terms of having a redox reaction. Electrons gained should be equal to electrons lost. So don't worry about the battery structure yet. This is just an example of where we're going to get to. So don't bother to familiarize yourselves with the parts and what they do and which way the electrons are going and all that, because I'll come back to that later on. Right now, all I want you to be able to do is look at a reaction and be able to recognize what's oxidized, what's reduced, what's the oxidizing agent, and what's the reducing agent. So just sort of get yourself sort of introduced to those terms. What does oxidize, reduce, what do they mean? Okay, and that that's kind of good enough for the first class. And then what we'll do is we'll start looking at more complicated reactions and figuring out how to determine the oxidation numbers, which will then lead us to how we go about balancing, which, like I said before, is very complicated. Okay, so we're going to have to spend a bit of time on just the balancing aspect. And there's a couple different methods that we'll look at that'll help you. Typically, one way generally works better for certain types of reactions in comparison to the other way. All right, so I'll stop there. So if you haven't handed in the acid-base exam, make sure that is handed in, and as soon as I get them all, I'll start marking them. So there won't be a class on Monday as it's a pro D-Day, so I'll give you the next class on Wednesday. So what I'd like to do is work on page 192, 1 and 2. Okay, and like I said, it's just kind of an introduction into some of these terms and identifying what's being reduced and what's being oxidized. Okay, so I'll stop there. Let me know if you have any questions, any specifics from these two questions, and I'll go over those for you next class. Okay, so I'll stop there. Again, stay safe, and I'll talk to you again on Wednesday. Okay, bye now.